Hello, my name is Abdelaziz Alsharawy, and I'm a PhD candidate at Virginia Tech's Economics Department. In this study, we investigate how arousal and attention interact in the decision process of risky choice. Incentives and uncertainty are the fundamental features of risky choice. Previous studies have suggested that risk aversion is quite not stable. For example, it changes with time, with environmental context, and with emotions such as fear. Also, a common finding in the literature is that risk aversion increases with stakes highs. When we look at studies that actually monitored arousal, we find that autonomic arousal increases when the incentives and uncertainty levels in the decision context increase. And this was not just found in value-based tasks, but also in perceptual tasks, and even in an airplane pilot decision-making study where student pilots were asked to land a plane in a simulator while varying the incentive levels. In cognitive neuroscience, there is this common theme that arousal has a modulatory role on attention and the information process, and there are multiple theories that try to tackle that point. And when we look at literature on visual attention and risky choice, we find that the most robust evidence is that of gaze bias. Simply put, people choose what they look at. And in this study, we try to look at these points collectively. And what we're interested in is to investigate how arousal and attention interact in the decision process of risky choice. In order to get there, we're going to start off with just looking at how autonomic arousal varies with incentives. Then we're going to go into how attention varies with incentives. And finally, we're going to put both of them together in a computational model in order to look at the interaction between arousal and attention in the process of choice. Just to give you a preview of our results, we find increased risk aversion, heightened arousal, and altered attention when payoffs were large and real. Also, we find that arousal modulates dynamic parameters of gaze bias in risky choice. In our experiment, participants completed a series of 80 lottery choices. These lottery choices were divided into 4 blocks. In the first block, participants were choosing between a safe option and a risky option. Here are the payoffs for the safe option. It was either $2 or 1.6. For the risky one, it was either 3.85 or just 10 cents. So you can see the risky option had a greater variability. We obtained these lotteries from Holt-Lowry table, if you're familiar with it. So as we move down the Holt-Lowry table, the probability of the high payoff or the good payoff increases. So participants are expected to switch between choosing the safe option somewhere here to choosing the risky option somewhere later on here. The later a participant switches, the more risk averse they are. So in the first block, we show these decisions twice for each participant. Then in the second block, we multiply these payoffs by 50, but we tell participants this is hypothetical block, you're not getting paid anything. In the third block, we use the high payoffs again, the ones that were multiplied by 50, and we tell them you're going to get paid for one random trial here in this block. For that reason, the average earnings in our experiment was pretty high. It was almost $100 per participant because of this block. And then in the fourth block, just as a control, we repeat the first block again. So we recruit 39 participants. Their average age was 22. Again, we have 80 trials divided into 4 blocks of 20 trials with in a block. And we eye track participants while they're making their decisions. So we have fixations data, we have saccades, and we have pupil diameter, which is our first measure of arousal. Also, we use BioPack to monitor skin conductance and pulse rate. You can see here how we presented the lotteries to our participants. So for example, here we have the safe option in the top and the risky one at the bottom. We have the good payoffs on the left, the bad payoffs on the right, but we randomize this order. So in a different trial, this participant may see it flipped right and left or up and down. And here is how Around progressed. So we start off with a 2-second fixation cross. This is where we measure arousal, and all the arousal results that I'm presenting today are measured during this 2 seconds. After that, we present the stimuli for 8 seconds. This is passive exposure phase. We call it evaluation phase. Participants are not allowed to make a decision here. Once these 8 seconds are over, 2 gray rectangles show up on the screen, and participants can move up and down until they select the option that they prefer. For our behavioral results, what I'm plotting here is the frequency of choosing the safe option, and on the x-axis is the probability of good payoff. Remember, participants are expected to choose more of the risky option as the probability of the good payoff increases, and that's why we see this downward trend here. This dashed line is the risk neutral prediction, and we see all of these lines are further away from risk neutrality, and participants are risk averse in general. Importantly, we replicate this result from Holt-Lowry, where this orange line supersedes the other 3, and it says that risk aversion increased when the stakes were high and real compared to the other 3 blocks. Then when we look at autonomic arousal, here I'm plotting the average z-scored of skin conductance, pulse, and pupil size across blocks, and we have this clear finding here that arousal increased when the stakes were high and real. Next, we were interested in the individual differences. So we focus on these 2 intermediary blocks, the high hypothetical and high real. Remember, these 2 blocks involve the exact same numbers. The only difference is that before the high real block, we told participants you're going to get paid for 1 random trial in this block, and we didn't say that in the high hypothetical block. We told them you're not getting paid anything. So we compute the first principal component for these 3 arousal measures, and we look at the change in this first principal component from high hypothetical to high real, and we plot it here on the x-axis, and on the y-axis I'm plotting the change in frequency of choosing the safe option between these 2 blocks. And indeed, we find this significant result that participants who became more aroused were the ones who were becoming more risk averse. And now I'll start off with a pretty simple drift diffusion model that takes arousal into consideration and allows its parameters to vary with arousal. In a nutshell, the drift diffusion model is a computational model of decision process where evidence is accumulated over time in favor of one of the alternatives. Once a participant collects enough evidence in favor of one of the alternatives, they choose it. The threshold parameter here determines how far these 2 barriers are from each other, whereas the drift rate parameter is the speed parameter that characterizes the evidence accumulation process. For now, let's focus on the threshold. I'll get back to the drift rate later on. So we take this threshold and we estimate a simple DDM, allowing this threshold to vary with arousal. We estimated using hierarchical drift diffusion modeling, or HDDM, and we find this pretty robust finding that increased arousal widens the threshold. This signifies response caution. So participants are becoming more cautious when they're more aroused. A similar finding in a perceptual task was reported by Cavana et al. In 2014. Also, when we look at attention and incentives, here what we're focusing on is the relative fixation duration, how long a participant fixated on each of these 4 regions here. So we divide our screen into 4 regions: safe good, safe bad, risky good, and risky bad. and we're plotting them here, and we can clearly see that participants under high real stakes fixated less on the risky good outcome, and instead they were fixating more on the safe outcomes, both good and bad outcomes. Again, we look into individual differences, and we find that participants who actually looked more at the safe good outcome and its probability, and less on the risky good outcome and its probability, were the ones who were becoming more risk averse. So by now I showed you two things. I showed you how autonomic arousal varies with incentives and how attention varies with incentives. And now we're going to try to put both of them together to see how do they interact in modulating the decision process. So the attentional drift diffusion model extends the DDM that I explained a few minutes ago to account for attentional biases. In particular, it allows the evidence accumulation for the fixated option to get a boost compared to the non-fixated one. So we obtained this model that was developed about a decade ago by Krabeck et al. And we extend it with arousal. So let me show you a sketch of what we call the arousal modulated attentional drift diffusion model that we develop in this paper. So we allow the drift rate now, the parameter that characterizes the speed of evidence accumulation, we allow it to vary with the gaze bias and the gaze bias multiplicative with the subjective value. So these are the elements of the attentional drift diffusion model. And we take that and we extend it further with arousal. We estimate this model using HDDM, but we needed to compute subjective values, and we do so using power expo utility function. Holt-Lowry showed that using this task, that a power expo utility function fits the data best. Also, we do separate analyses, once for gaze obtained during evaluation phase, and another time using gaze obtained during the selection phase. If you remember, this is after the 8 seconds that I explained earlier. So let me show you the attentional biases that are accounted for in our model. For example, if a participant is evaluating the $100, which is the safe good outcome and its probability, we allow this evaluation to vary based on where participants were looking exactly on the screen, if they were looking at it, or if they were looking at the safe bad outcome, or the risky good outcome, or the safe bad outcome. This is the model as a whole. It looks overwhelming, but the idea again is a bit intuitive, where for the good outcomes, we allow their evaluation to vary based where we're looking at. These are these 4 colors here. For the bad outcomes, we do a similar thing, where we also allow them to vary based on where we're looking at. And we add additive gaze bias that is independent of subjective value. So this is how much participants were looking at the safe good attribute instead of the risky good attribute. And this is how much they were looking at the safe bad attribute instead of the risky bad attribute. And it's not multiplied by the subjective values. We take all of these model elements and we interact them with the first principal component of arousal again, of skin conductance, pulse, and pupil size. For inference, the question that we're asking here is, does arousal amplify attentional gaze bias? And is there gaze bias in this task? So we look here at the good attributes, and we're seeing how participants were evaluating the good attributes. What I have here is the evaluation of the good attributes when participants were looking at the good attributes. And these are the 2 coefficients here in blue. We subtract this from the parameters of the evaluation of good attributes when participants were looking at the bad attributes. These are the two coefficients here in red. If this yields a negative coefficient, it suggests there is attentional gaze bias. In which direction? In the direction of good attributes being discounted when participants were looking at the bad attributes. Then when we look at these parameters when interacted with arousal, the inference is pretty similar, and we see whether arousal enhances this attentional bias or attenuates it. An analogous inference is that for bad attributes. The only difference here is that we're looking at whether bad attributes are discounted when participants were looking at good attributes or not. So let's take a look at results. What I'm plotting here is the posterior parameter value for the difference in these coefficients that I showed you in the previous slide. And here is a density plot here. If they're centered around 0, then there is no evidence for attentional gaze bias. Interestingly, we find that for bad attributes, they are evaluated the same whether participants were looking at them or not. On the other hand, for good attributes, we find these posterior distributions really far away from 0. And what this suggests is the following. So this suggests that the good attributes were discounted when participants were looking away from them, when participants were looking at the bad attributes. Importantly, we find that arousal, which is this dashed line here, arousal amplifies this process further. So to wrap up, we find increased risk aversion, heightened arousal, and altered attention when payoffs were large and real. Also, we find that arousal modulates dynamic parameters of gaze bias in risky choice. In particular, good attributes values are discounted steeply when attending to bad attributes, with heightened tonic arousal further amplifying this process during evaluation phase. I would like to thank my co-advisors, Dr. Alex Smith and Dr. Cheryl Ball, and my colleague Shaman. Please reach out to me with follow-up questions at my email, sharawi@vt.edu. Thank you so much for your attention.